Okay, so I'm going to talk about three classes today. We're going to talk about the string, we're going to talk about the list, we're going to talk about the map. So as far as things go, when you're writing Java programs, probably 99% of your code will be around these three things. And most programs you write will deal with strings. Most programs you write will deal with lists, maps. It's not unusual to have a combination of those in nearly every program you write. So it's really good to have a good understanding of how those classes work and some of the methods that are already provided for you when working with those classes. Okay. So objectives for today, we want to talk about the string class, we want to talk about the ArrayList class, we're going to talk about hash map. We're going to talk about how those fit together, and we'll look at a lot of the methods and features that are built into that. Okay. So important thing to remember with strings. Strings are always immutable in Java. It's a really critical thing to remember. So anything I do that would modify a string means that I can't modify the string, I have to make a copy of the string. Okay. So if I want to do things where I modify strings without making copies, I need to be using String Builder. And in a lot of ways, String Builder works very similar to a string. It's just a string I can modify. Okay. And what I mean specifically by them being immutable is I'm saying that once I've created it, I can't change it, right? I have to make a new copy, a new object. So as we're following along here, I would strongly advise opening up the Java doc for the string class because we're looking at a good number of methods in the actual string class. And there's a little bit more documentation than what I have on the slides there. Okay. So the first thing you'll notice, if you look at the top of the string docs, okay, you should notice that it implements some interfaces. Okay, what interfaces does the string class implement?
It says serializable.
Serializable, okay.
Char sequence, and then parent.
Okay, so serializable means that you can save it to disk. It means there's some way to save it to disk. So that's what that means anytime you see it. Comparable means I have that compare to method and I can figure out the sorting order of different strings. So I can say, does this string come before that string? So I can sort them alphabetically. Okay. Care sequence is the one I really want you to call your attention to. So string implements this care sequence interface. Care sequence is basically anything that looks like a string is a care sequence. So there's a bunch of classes that implement that interface. Okay. So if you look at the documentation on care sequence, you can kind of follow the link on the implements clause and it'll take you to the documentation. The important thing to note there in the overview, it says a care sequence is a readable sequence of character values, and it says this interface provides a uniform read-only access to many kinds of care sequence. So what is that saying? Well, anything that's a care sequence is just, it's a sequence of characters. Okay, so that's a lot of things. So that can be things that are both modifiable and things like string that are immutable. Everything implements that. One of the things that means that as you're looking through the API docs, both for Android as well as for Java, you're going to see a number of places where it either returns a care sequence or it passes a care sequence. Well, that means you can give it anything that implements care sequence. Okay, so that's a lot of things. So let's look at just part of that hierarchy. So we've got the care sequence interface. A few common things that implement that in Java. We got string and string builder, right? Both of these actually implement the care sequence interface. So if I need to use something that takes a care sequence, I don't have to take it out of the string builder and turn it into a string. That's one of the things that means. A lot of people make the mistake and say, okay, I'm going to call string builder.toString and then pass that into this method. You didn't have to do that. You could have just passed in the string builder. So there's a lot of methods to just take a care sequence, and that means you can avoid a copy. Because if I say string builder.toString, I'm immediately making a copy of everything that's in string builder. Okay. The other things that these are in Java. There's also two very important classes in Android, which we'll see as we get into working with text fields and such, there's android.text.editable, android.text.span. Because in Android, not only can I have strings that have characters, I can also have formatting attached to those strings. So I might say the first 3 characters are bold, and these other characters are italic or underlined, or this is in red and that's in green. All of that formatting is contained in these objects, span and editable. So we'll actually see these come back as we're working with text fields. Now those implement the care sequence interface, but they're not actually strings, right? Because they have additional data on them, right? They have additional formatting data on them. So what that means is I want to pay attention to what can I do with a care sequence, because I can do, if I don't have to take these things and turn them into a string, I can make things a little bit easier when I get to the world of Android. Okay, does that make sense? So you can see there's a lot of things that behave like strings. So a lot of times, if you can, you want to write your methods to deal with care sequences instead of dealing with strings. Take care sequence as an input instead of taking string as an input. Okay. So constructors on the string class, not that we'll call these very often, but there's basically 3 there that really make sense to look at. There's a few others that deal with byte arrays and such, which is quite a bit more advanced anytime you're doing something with that, because then you have to get into how does Unicode work if you're using any of the versions that take a byte array. But these are the other 3. So the first one, string, default constructor, takes nothing. If you read the documentation on that, okay, you can actually go, if you're looking at that class on the Java doc, you'll see this little text on the constructor. Know what that last sentence says. What does that last sentence say? What is it telling you? Say creates an empty string, and oh, by the way, never uses, is basically what they're saying. Because if you want an empty string, you should always say double quotes instead of using that constructor. The reason being, if you say new string, you're always forcing it to create a new object. If I say double quotes, it can actually reuse any other empty string that you've got in your program. So anytime you, one of the things to know with strings, anytime you create a literal value, so like I say, hey, who, or hello, or world, or just empty string, any constant string constants that I have throughout my program, they get put into something called the string pool or the literal string pool, and that means they get reused. So if I write empty string, empty string, empty string all throughout my program, I'm actually only working with one object rather than working with an object for each time that occurs. Does that make sense? So it actually optimizes it out. It's actually better not to use the constructor most of the time. There's also, if you say new string original, pass in a string, that will then create a copy, right? So this is creating a copy of that string. Again, you basically never need to call that one because strings are already immutable. So there's no reason to make a duplicate unless you're, for some reason, trying to test something out. But typically, we never call that one. Now, this one is interesting too. There's a third one that takes an array of characters. So for some reason, I'm dealing with characters, I'm doing some work with that, I can then take that character array and turn it back into a string by just passing it into the constructor. One thing that's worth noting here, contents of the character array are copied, right? So they are copied. There's no way to get around that with this constructor. Okay, what does that mean? Why are they copied? Why couldn't I just take the character array and just put that into my string?
Would each point in memory, or so if you just copied the character array into a string, because the character array, each element functionally it's just a reference to something else.
So, okay, so let's say I've got a character string here, just for illustration purposes. Let's say I've got an array here. So I'm going to say, let's actually put this in code. So car array, and call this variable hello, and I'm going to set it equal to maybe I'll just do hi, keep it short. Right. Now I say string s is equal to new string hello. So are we clear on what's happening on the second line? So I'm taking this character array that's got H and I in it. I'm going to end up with a string that's got those two characters in it. I'm going to say hi, right? Now, what happens if I say hello, 0 is equal to x? Okay, so I've changed the array. Should the string also change? It should, right? Why should the string not change? Alex.
The string has a different memory address, or like it's allocated in a different part of memory.
Well, the string object is, but is the character array inside of the string in the same place?
No,
Okay, why is it not?
it made a copy.
It made a copy, right? So if we didn't make a copy, if this constructor did not make a copy, if I change it here, then S now contains XI instead of HI. So that's why it's making a copy, is because strings need to be immutable, right? So if I didn't make a copy here, I wouldn't be following that part of the contract that strings need to be immutable. I would now have S as a string that could be mutated, as long as you have access to the original array. Does that make sense? So there is a copy that happens anytime you call that. Okay. So what does that mean? From a performance standpoint, you only call that as few times as you can. So if you need to take your character array and you need to turn it back into a string, maybe you do that at the end of your function instead of inside of every loop iteration. That makes sense? So those do exist, but just be forewarned, those are usually not things those are usually things that you want to avoid. You usually want to avoid saying new string as much as you can. And if so, maybe it's just that third one and you do it once. Now, working with strings, you can get the length. You've seen this for sure as well. Length, char@, that will give you the how big is it and what character is that. Okay. Now, reminder, again, if I'm dealing with arrays, how do I get the length of the array? Dot length. But is it with parentheses or without? It's with? All right, so show of hands. If I'm getting the length of the array, do I need to include parentheses or no? How many for yes? How many for no? Okay, the answer is no. So when I'm dealing with arrays, it's not with parentheses. Now, dealing with literal arrays is the only case where I get to leave out the parentheses. Anything else, if I'm dealing with a string or if I'm dealing with a collection, a list, a map of any sort, that's always going to be a method call. The only time where it's not a function call is where I'm dealing with a raw array. Now, that length property is a little bit interesting in the sense that it's one of the only variables in, it's one of those few variables that's read only. Okay, kind of looks like a property, as you might be familiar with C#, but I can't set the length. You know, I can get it, but I can't set it. Okay. Other useful methods that you'll find in the string class. You'll see there's a function called starts with, and there's a function called ends with. So starts with says, does the sequence of characters appear at the start of the string? Okay. Call that a prefix. But note that it's only checking at the beginning of the string. It doesn't check if that occurs in the middle of the string, right? So starts with is specifically, I want to say, does this happen at the beginning of the string? Okay. Ends with similar thing. I can say, does it end with the sequence of characters? Keep those handy. Those do come up. Occasionally they are useful, but you do want to keep track of what's what. Okay. There's also two very similar methods to ends with and starts with, but they're a little bit more general, okay? But they function in a similar way. So I say, first of all, note that ends with and begins with, what data type do they return? They return a Boolean. They just say, is this true or false, right? Because I don't need to know what array index it is. I know that if it begins with, it's 0. If it ends with, it's length minus 1. So I don't need to know where that occurs. So index of and last index, index says go search through the string and see if this substring occurs anywhere. That makes sense? So if I say go look for in hello world, go find the first place that I see world. I'll give it that string and it'll tell me, okay, it's index 6 or whatever. It'll come back and tell me the index. If it doesn't find it, it'll be -1. Okay, so index of is a way to search. Right, so index of, last index of, both ways to search. Char at just says, hey, give me the character at this position.
So if you're passing a character, the int is pretty obvious what it refers to the index. So passing a string like world, will it pass in, or will it return?
It's the index of that first part.
Okay.
So where does the substring start? Okay. So in hello world, if I ask for where does world start, it would say it starts here at this character. So doing my math, there's 4 characters here, 5, so this is 6. Right, this 6th character, or 0, 1, 2, 3, 4, 5. Yeah, that's 6. So it would give me back index 6, be where it starts. Same way, actually ends with would return the same thing here. It would return 6. The difference between, last index would give me 6 as well. The difference is that index of searches from the beginning and finds the first occurrence, whereas last index searches from the end and finds the last occurrence. That makes sense? Sometimes you want to search from the beginning, sometimes you want to search from the end.
Wouldn't it return 5 though, because it starts counting at 0?
So 0, 1, 2, 3, 4.
Okay.
And then there's a space, which is 5.
Okay.
So it's actually at 6.
Okay, I
You have
just
to-
counted then.
Yeah, you just have to make sure you're counting that space. Okay, so those are both helpful if you're looking where does the string occur inside of another string. And both of those return -1 if it doesn't occur. So let's say I had hello world. So in this case, what would I get? Well, starts with would still return 6, but ends with would return that number right there, right? This would be starts with, this would be ends, or sorry, index of, this would be last index of. So I'm going to get different answers depending on which one. But note, either way, it can only give me one answer, which is why it has to choose between give me the last one or give me the first one. I can get all of those occurrences that way. once I've called either index of or last index of, it's pretty common that you're going to then want to call substring. And you may want to call substring in a lot of other cases, but those commonly go together. So substring says, give me just part of the string. Give me this part of the string. So I say, what's the index you want to start at? What's the index you want to end at? Now, this is different from the substring method in C# in the sense that what the C# version takes is actually different parameters. It takes two integers, but they're two different integers. So if we're looking at C#, the signature actually for this was begin index and length. How many characters do you want? Not what's the index of the last character. Does that make sense how that might be different? Might give you a different answer. So if I wanted to start at index 3, give me 2 characters. In C# I would have said 3 and 2, but here I'm going to say 3 and 5. So it's a different kind of parameters.
And that last one's not inclusive, right?
So it's not inclusive. Yes, that's important. So we do include the first character, we don't include the last character. So for instance, if I say 5, 5, I actually get an empty string because it doesn't include the last character. If I say 5, 6, I'm going to get a 1 character string. 5, 7, I'm going to get a 2 character string, etc.
Would it be a compile time or runtime if I put in like 5, 4?
Well, think about that. What makes sense? Would the compiler know what size your string is?
No.
Probably not. So no, it's generally going to be a runtime error. You have an invalid index here, you're going to get a runtime exception, and it's probably going to be array out of bounds or similar. But you're not going to get a compile time error for it. There's also a very useful method for a lot of programs called split. If you call split, you can say, okay, we'll split it based on spaces or commas or semicolons. Whatever you need to split it on, it'll take that and use that as kind of the separator between values and give you an array. So for instance, if I had a string, let's say we start with that string first, hello world world, and if I say we're going to split on spaces, so I might say this is string S, and if I say let's get that split string array, say words, I want to split it into words, I could say s.split, and I could split it on the space character. So then I get an array here. Words would contain hello, world, and world. Or if I had another string here where I said I had 3, 5, 7 as my string, I could say, well, let's split on commas, and that would give me 3, 5, and 7. So there's a lot of places where this can be useful. We're splitting strings. Okay. There's 2 versions of it. One that just takes a string, which is what are you going to split it on, and another version that also takes a limit. Okay. So the limit kind of says, I only want to match up to this many times. Right. By default, that's set to 0. Which I think that definitely at the moment, go ahead and bring up the Java doc and look at that version, the version that takes a limit.
It's 0.
It is 0. Go ahead and take that. There's a chart there that I want you to look at, though. There's some documentation that I want you to look at on the split method. Because there's some interesting behavior there with how that limit works. Okay. So if I set it to a positive number like 3, then the biggest array I'll get back is 3. I'll get at least 3 matches. And what it'll do, let's say for this, if I say split 2, split in commas, get 2, the array that I'll get back would look like this. So I'd have 3, and then the second entry would be 5, comma 7. If I give it a limit, then that last entry is everything that's left over. Typically is how that works. Okay. Now, if I tell it 0, what does it tell you about 0 in the documentation? Because 0 is the default if I don't specify it. What does it say in the Java doc for string? For string split. So you've got it open. There's an interesting caveat there on number 0. You see it? What does it say happens for if you put 0 as the limit? That's the way we read it out. What does it say? Limit is 0.
Then the pattern will be applied as many times as possible. The array can have anyone and trailing empty strings will be discarded.
Notice that last part. Trailing empty string will be discarded. So one of the things that that means is that it's got a little bit of different behavior with spaces or extra space at the end. Okay. So for instance, let's say I write my input as such, comma, comma, I put 2 commas at the end. What would you expect for my output of split to be, given that? What should I get as my output? Here.
Oh, based on the 0?
Based on, I'm not giving a value, so it's 0. Remember, not giving a value is same as 0.
Right.
So what is my output here? What is this array? What are these arrays? What am I having in words? What's my first entry? 3. Okay. What's the next one? 5. Okay. What's the next one?
That's the last.
That's the last one. And these are actually strings, but that's the last one. Okay. So if I leave it as 0, it's going to get rid of these 2 empty strings. See, because I've got these extra commas at the end. If I specify it as a negative number, let's say I specify it as -1, it's going to actually give me a different answer. So there it's going to give me 3, 5, 7, empty string, empty string. Sometimes this is the answer you want. A lot of times that is because you just want to say, well, the spaces at the end, that empty stuff, I don't care about. But there are cases where you want this, and that is one of the cases on one of the Code Wars problems is you need to do -1 to get this out. Does that make sense? So default behavior throws away any empty strings that you've got at the end. That's just one thing you need to know about split. Okay. Oh, again, that's the default behavior because for most programs, that's what you want, but it's not necessarily the case for all programs. So if you give it a negative value, it will do that. It'll keep the trailing spaces. Of note, if I had an extra comma in here, that's always treated, that's always maintained, regardless of what you set the limit to. So that would still be maintained as an empty string in the middle. It's only eliminating empty strings at the end. The flip, basically the exact opposite of doing a split is doing a join. So a split takes a string, separates it based on where you want to separate it on, the delimiter, and then a join puts it back together. Now, one thing I might note on here, notice the name, before we leave split, notice the name of the first argument. What is it? First argument to split is regex, okay? So it will be treated as a regular expression, okay? Which means you do have to be a little bit careful as to what you give it, okay? So for instance, if I say string split plus, that's not a valid regular expression. That won't split on pluses. So you have to kind of be aware of some of those things. So I might want to, if I wanted to split on plus, I'd have to do // I think, yeah, // plus. It also means that you can, though, do things like // s, and that would be all white space. So rather than just saying I only want to split on spaces, I could say I want to split on all white space using // s. S is the character class for white space. So there's a lot of power that you can get from that being a regular expression, but you just need to be careful because it's going to be treated as a regular expression. So one of the things that means is don't take user input for that. Don't let the user enter what their regex should be. That would be a case for sanitizing your inputs. It's okay for you to hard code what the splitter should be, but don't take that usually as a general rule. You really want to avoid having the user enter that. Okay. So for join's going to take this array of strings that you split apart and put them back together. Okay. So notice that split, it was a member method, right? It was a method. You had to have an instance, it was an instance method. You had to have an instance of a string called split. Versus join, going the other way, because we're going from array to string, is a static method. So when I might say s.split, I'm going to say string.join. You put it back together. So let's say, going back here, if I want to take this thing with commas, I want to take it, I want to put it back together. I'd say split it and then join it. So if I say string, let's call this u is equal to string dot join. I'm going to say join it on, let's say join it on semicolons. And give it the words. So I've broken it apart on count commas and then put it back together with semicolons. That make sense? They're kind of backwards of each other. One breaks it apart, another puts it back together. So anytime you have a list, or anytime you have an array of some sort that you need to put back together, join them together, you can use this join method. Yes?
People use that to like replace characters in the string.
What do you mean, to replace characters? The split and
If
join?
if I have like, I want to replace n, I can split on n and then change them to n.
No, it's actually easier than that. You just say join, or you just say replace. We'll get to that in a method. There is actually a replace method, so that's actually quicker. So notice that the first thing we take in is a char sequence delimiter. Again, remember what I said about char sequence, right? So string is a char sequence, but this doesn't just work with strings. See that? It can actually take anything that implements a char sequence interface. So I can actually put the string builder or whatever else I need to put in here. I could actually put anything there. It doesn't have to be a string, but it will work with strings. Okay. So that's the first argument, is the delimiter. It's what I want to put in between each of the strings. It will go ahead and not put one at the end, so that's also already built in there. You don't have to go chop off the one at the end, because that's often the thing that people forget. There's something interesting happening though with the second argument. You see char sequence ... What does that mean?
You can put in multiple inputs, like say you say multiple strings without having it be an array.
It's what we call var arcs. That ellipsis is what we call kind of var arcs. There's a variable number of arcs. So I can call this join in a few different ways. Okay? So I can call it with an array. Anytime you see that ellipsis, I can call it with an array. But I also could call it with words literally. So I could say string dot join. I could say join it on semicolons or spaces or whatever I want to do there. Maybe I say comma space. Let's join it on comma space. And I'm going to put in here a Lincoln. So that ellipses means that this is also valid syntax. I can put a sequence of strings, put them in as arguments, or I can put in an array. Most of the time it will be explicitly an array. But it does mean I can't give this a list. So a list doesn't actually work as the second argument, but an array does. Fair forewarning. I can put it back either way, but I can't use a list. Also worth seeing as far as working with strings, there's a few different methods to compare them. These first three all check for equality and they return booleans. So you've got equals, which is every class that's an object has to implement equals. So that says, are the two strings equal? Exactly. There's also a useful one called equals ignore case, which will compare them, and I think I've shown this with most of you. We'll compare them without considering the case. Okay, so that's helpful as well. There's also content equals. Content equals comes from the char sequence interface. So anything that's a char sequence has to have content equals. Well, content equals takes the character sequence. So if I got two character sequence I need to compare, maybe one's a string builder and one's a string, or vice versa. Maybe I've got two string builders I need to compare. I might want to use content equals instead of equals. Does that make sense? That doesn't get used very often, but if you're doing something where you're working with just char sequences, you may want to keep that one in mind. Compare to, remember compare to comes from the comparable interface. And it says, okay, -1 I think occurs before, 0 is their equal, positive is thereafter. So you can use that to sort strings. So there's compare to, which will sort them alphabetically. If you want to sort them alphabetically, ignoring case compared to ignore case. So you can either sort them case insensitively or you can sort them case sensitively. It's got both. So both of those can be useful for sorting or for checking for equality. Okay. There's also some methods, 2 lowercase, 2 uppercase. Note that these are a different name than they were in C#. Remember, they were 2 lower and 2 upper. So that may trip you up for a little bit as 2 lowercase, 2 uppercase, but that's what it is. Also note that they start with a lowercase letter, just like every method in Java starts with a lowercase letter. Okay? Which tells you to know. Now, there's actually 4 versions here. You'll see that's on the table here. So I've got 2 lower, 2 upper. I've got 2 of these versions that don't take any parameters, and I've got another 2 versions that take something called a locale. Okay, so one of the things to know is that in English, right, there's always uppercase letter to lowercase letter. It's always a 1-to-1 ratio, right? An uppercase L is, and there's an lowercase L. There's no alternatives for making something uppercase or lowercase. Okay, that doesn't exist in all languages. Okay, so sometimes in some languages you have, if I say make something 2 lower, 2 upper, I potentially lose some information because they have different versions of the same character, right? They don't have a 1-to-1 between uppercase and lowercase characters, which gets very interesting. Okay, so and that changes based on like where you live, what country you're in, what language you speak. So that's where you oftentimes, when you're dealing with comparing things in a case-insensitive way, making things uppercase and lowercase, it depends on your cultural information. So if you're dealing with, especially as we're dealing with Android, well, we want to be able to ship these apps all across the world. Well, if we're dealing with somebody in a different country, uppercase and lowercase may not be the same. They don't work the same way as they do in English. Does that make sense? Or there's one version of it in lowercase, there's 2 versions of it in one version of uppercase, 2 versions of lowercase. That happens in a few different languages.
Or the language might not even have to use a case system.
Most languages have case, but it's just not necessarily a 1-to-1 between uppercase characters and lowercase. Does that make sense?
Yeah, it's like thinking of it wouldn't necessarily, like languages don't necessarily need them.
Yeah, it gets weird. Yes. So if I think about, for instance, Arabic doesn't really have uppercase and lowercase because of how it works. Chinese doesn't really have uppercase and lowercase, again, because it works. So that's the thing to keep in mind. If you just call 2 uppercase, 2 lowercase, you're using the default locale, okay? Default locale, which means, for instance, if I'm running on my American smartphone, well, that means I'm using the US locale. If I'm running your app in China, well, I'm using the China locale. If I'm in Belgium, well, I have the Belgium locale. So the way that upper, 2 lower, 2 lower, 2 lower, or 2 upper works may change depending on where I'm located around the globe. Okay.
Is it an email locale?
Locale is an object. Locale is an object.
Does it just have like a ton of like static fields or something?
There's a bunch of ways. There's a way to get it. So for instance, locale's got a static method locale.getDefault. That will give you the default locale, which is what these 2 versions do. They just call locale.getDefault, but there's ways in locale that you can get, say, I always want to do this in the US locale. So you can get the US locale and use that instead. Things like that. So that's the thing to be wary of. Note that there are those other versions, and as you're dealing with international code, there's a very good likelihood that you'll need to look at those. And be aware that that's happening. Because it's not unusual to have your app running in different languages. Again, that's why I have that. There's also 2 useful methods with strings. There's one that's IsEmpty. IsEmpty will say, is the length 0? right? So you can do that by checking length, or you can just do that by checking IsEmpty, which is a little bit more descriptive. There's also a really, really useful one here called isBlank. IsBlank is basically similar to, remember in C# where I showed you, hey, use string as null or white space. This is basically that part. But it's only half of it. This says, is it white space? So you can call isBlank and that'll tell you, is it either empty or is it only containing spaces? So that's a really good thing as you're checking inputs and making sure that they have actually given you a valid input. You can say, okay, well, if it's blank, then treat it as if the user hasn't typed anything in. So that's worth knowing that that is there. There's also another two methods called trim and strip. Trim works similar to what you saw. Both of these work similar to what you saw in C#. What they'll do is they'll take out all the white space at the beginning of a string and all the white space at the end of the string. Anytime you take user input, I don't care whether it's from a text field or from the console or where, you should trim the inputs that you get. You should use that to remove any white space that is the beginning of the end, because that's usually user error. Okay, it's very, very infrequent that you want to pay attention to white space at the beginning or end. So you usually want to make sure that you trim as stuff is coming in. Now, things get a little interesting in Java because they've decided to add these two different methods. So there's a trim and there's a strip. And you have to read really closely into what they do. So if you look, just a general kind of perception, let's look at the first one. It says, returns a string whose value is this string with all leading and trailing spaces from it. Stop there, okay? This one says, return a string whose value is the string with all leading trailing white spaces from it. So these do the same thing, right? There's no difference between trim and strip, right? At least according to that. Okay? They both remove white space from the beginning or the end. Problem is they define white space in a different way. Okay? So trim works just fine as long as you're working with just American, English. Just working with Latin languages. Because what it says, the way it defines a space is anything that's Unicode 20 or less. Which actually includes some things that may or may not be considered space, but that's that. So there's 20 different characters that it turns in space. Does that make sense? Or 21, actually counting 0. So those 21 characters are treated as space, and everything else is not treated as space. The reality is that's not all the spaces in the Unicode spectrum. There's a lot of, there actually in the Unicode language, there are spaces with higher numbers. So what that means, that's why there's two different things. This one says, is the character white space, which actually will go through every possible Unicode character and check for space. So the gist is this trim works just fine. Again, as long as you're working with English. You may need to call strip if you're working with other cultures. Does that make sense? Because there's other characters that this doesn't move. Okay. You're asking about replace. There's a replace method. It's called replace. So I've got a few different methods here. Let's start with the top. So replace. This version of replace takes a character. So this will say every character that is old car, replace it with new car. So that's what I might do there. I'd say replace all commas with semicolons. Be a quicker way to do it. Now, so this version just takes a single character. We'll replace it with a single character. There's also a version that takes an entire sequence. Again, that can be a string or anything that behaves like a string. Say replace this string with that string. So if I want to say place all instances of apple with orange, I'd say replace apple orange. That makes sense? That's what I would do there. So I can do replace this with a string goes to a string, or I can do just single characters. This is more efficient if you only have a single character. If you have more than one character that you need to replace, definitely use this one. But if you only need to say change semicolon, commas, semicolon, then definitely use the first version, which means that you want to use single quotes to get this version versus use double quotes to get that version. That makes sense? There's also another version here, replace all. More than likely you want to stick with these two. But if you do need regular expression support, that's where you're going to go use this one. You see how it says regex, just like we were looking at split a minute ago, and the argument was named regex. So this one actually behaves differently. Replace all, replace is different than replace. Replace is just a literal value, and replace all, it assumes that's a regular expression. That's the difference between those two. So typically this one's faster. If you need a regular expression, you go with this one, but if you don't, use that one. Okay. I won't go too deep into these because we haven't talked about streams yet. So we may come back to these. But there's a new API that's been added with Java 8 that kind of works a lot like link. We call it the streams API. There's 3 methods that they've added to the string class, and they kind of give you the stream in different ways. Stream, again, we haven't gotten to it yet. We'll talk about that later. The first one gives me the characters as sort of a stream of integers. Now remember, what size are characters in Java? How many bits are they? Is it 4? Or 8?
Is it variable?
It's not variable. It's always a particular number. So the car data type is always 16 bits.
I misheard. I thought you said string.
Sorry. Yeah. Car is always 16 bits in Java. So if you remember, ASCII is based on 7 bits and usually stored in 8 bits. Unicode is actually 32. Unicode characters are actually 32 bits wide, which does mean that if I'm storing things in 16 bits, sometimes those characters actually span 2 characters. Sometimes 2 adjacent characters actually make a full character. Okay, and that's where we call this UTF-16. Okay, so we can also see UTF-8, which is coded as 8-bit chunks. So if I say cars, what it's going to do is it's going to take all of those characters, expand them to integers by just adding zeros at the front. Okay, which means that it'll work just fine again for English, but may not work well once you go to throwing emojis in there. So cars might not work the way you want it if you've got emojis in your string. Code points, that's what we call it, which is the 32, will actually go and take care of those characters that span 2 parts, that span 2 chars. That makes sense? So if I'm dealing with international languages, I want to make sure I'm using code points. There's also another one that says lines, which will give me a stream, and it'll just split it based on the line terminators. So all of these can be useful when we go to talking about streams to take a string and turn it into a string. Okay. If you want to read more about the string class, here's a link to a tutorial. There's definitely more to be learned about the string class, but that's a broad overview of most of the methods we end up using. Okay, but there is more to read there if you want to find out more about that. Okay, any other questions about strings? Hopefully that gives you an intro to some of those problems. Part of the reason I bring up all those methods is there are problems when you get to your code wars problems. Some of those need some of those additional methods. You may not have used some of those when you went through the console program, so you'll definitely need several of those for code wars.
How does the assignment operator, does it use the replace, or how exactly does that work?
So what do you mean the assignment operator?
So like when you have a string that's already equal to like hello, and I want to set it to world,
Yeah.
Does it, like, does it use any of the methods in the back end or like behind the scenes or?
No, it doesn't. Just a reminder there. Remember, strings are immutable,
Right.
which means I can't change them. Okay. So if I say, let's start with string S is hello. Let's start with that. Well, then if I go and say S is equal to world, hello is never there, is no longer there.
Right.
Right? If I look at the memory, I've got here originally I had S, was pointed at the string hello. When I reassigned it, I went and changed that. Changed it from being pointed at hello to now being pointed at world. Hello's still there in memory. It's never changed, right? It hasn't changed. So I'm not, if you're thinking about replacing, I'm not replacing anything.
So the confusion that happens for me is like, if strings are mutable, how can we use the replace and change certain characters in a string?
So most of these methods inherently have to make copies, right? So if I want to say in the hello, let's say we say S is equal to S dot replace, and replace the L's with X's. So I say replace L with an X. So I'll start with it being pointed at hello. I'll build up this new string, and this new string will be over here, HEXX. It's not changing the original thing. I had to make a copy.
Okay.
Now, if I'm using a string builder and I call replace, it will change it in place. Because remember, a string builder is immutable. So there's also a replace method on the string builder.
Mm-hmm.
And that way, if I don't want a copy, I use a string builder. So I can avoid some of those copies. Does that make sense?
Yeah.
But if I'm calling anything like this, split, substring, replace, to lower, uppercase, all of those inherently have to make a copy because I can't change the original. Does that make sense? All of these methods don't get around having to have the original be immutable, so they have to make a copy. Which also means I can't just say S replace and not assign it to anything. I'll just be throwing away the result. I have to say S equals S dot replace because it's returning a new object. It's not changing the existing string. Does that make sense? Okay, so list. Before we get too much into the actual implementation of the methods, let's talk about the actual class hierarchy. So if we look at the top, if you go look at the list interface in the Java docs, you'll see that there's a kind of a hierarchy of classes. So up at the top, we have this iterable interface. Iterable interface means I can iterate over it, right? Anytime you see that bold at the end, that means you can do something. So comparable means I can compare it. Iterable means I can iterate. So iterable only has one method that returns an iterator. I believe it's called iterator. So anything that implements the iterable interface can be used with the for each loop. That's what you need to know. In order for the for each loop to work, it has to be iterable. It has to implement the iterable interface. Okay? So that's all the way up the top. everything we're looking up here implements that, or is kind of derived from the iterable interface. The next thing that we have down here is something called a collection. Okay? A collection is a group of elements. It doesn't have to have an order. Collection does not require there to be an order. And it does not require for you to be able to modify that collection. That's not inherently required. Okay, so some collections are read-only, some collections are modifiable, some collections have a defined order, some of them do not have a defined order. Okay, some of them allow duplicate values, some of them don't allow duplicate values. So you have to kind of look down at the hierarchy to know what kind of those rules apply. Make sense? So a lot of methods in the framework take collections, just to be very general. They take collections, similar to where you'll see a lot of methods in the framework take care sequence instead of just taking string. Okay? So a lot of methods take collection, which means you can give it anything that is a collection. Okay? Now, underneath collection, there's two important sub-interfaces. We're still, all four of these top ones are still interfaces. None of these are classes. So set is a group of elements that doesn't have an order, typically. Sets don't have order, but they are required to have unique elements. You cannot have duplicate elements in a set. Okay? You cannot have duplicate elements in a set. Versus a list does allow you to have duplicate elements. Okay? Another thing worth noting, I believe that the size method, that comes from collection. So anything that is a collection, you can find out the size of. Anything that's iterable doesn't require you to know the size of it. Okay, so this could actually be, iterable could actually be an infinite thing. It could be numbers from 1 to infinity. You could actually have that be an iterable object. It wouldn't be a collection because it doesn't have a defined size, but it could be an iterable. Okay? Or give me all the prime numbers. Well, that could be iterable, but it wouldn't be a collection because it doesn't have a defined size. So set typically doesn't have an order. List must have an order. Set cannot have duplicates. List can have duplicates. So I can say I want to put Ashley in there twice. I can put Ashley in there twice in the list, but I can't put that in there twice with a set. Okay. So array list and linked list, these are the kind of the most commonly used implementations of the list interface. Okay, and they work very similar. But the point is, that's where they land, right? These are the actual implementations of list. Now, typically, what you want to see most of all in your program is you're going to see this list, because you don't usually want to know what kind of list is it. Is it a linked list? Is it an array list? You usually don't care. So you want to kind of treat all lists the same, or you may in some cases say, I don't even care if it's a list, I just care that it's a collection. So typically if you're building something you want to be really, really reusable, say it takes a collection. Because that would be the most general. So does that make sense? Where some of those properties come from? That's kind of where you have to be aware of all of that hierarchy, because you'll see that as we go. Now, list interface. If we go look at the overview, we can see kind of the definition of what is a list. It says it's an ordered collection, also known as a sequence, and the user of this interface has precise control of where each element in a list is inserted, and the user can access elements by their integer index, their position in the list, and search for elements in the list. So what that means is, and the reason why that's saying that is because remember, collection doesn't have an order. Collection does not require your items to have an order. That's required by lists, and lists are required to you be able to say, okay, I want index 3. That's defined in list, but it's not defined in collection. Okay, so I can iterate over the elements in collection, but I can't say I want the third index if I just have a collection. Sorry, the third item. Okay, so ArrayList, linked list, they both implement the list interface, but they're implemented very different underneath. So an ArrayList, as the name says, on the back end is implemented with a list. Okay. Now there's two counters inside of an array list. One is the size, one is the capacity. Capacity is how much space is reserved in memory for it. How much space does it already ask the system for, right? That's how much space it's using. But the size is how many elements have you added to it. So in this case, my capacity is 8, but I've only added 6 things to it. Okay, your size will always be less than your capacity, less than or equal to your capacity. Your capacity typically goes up by a factor of 2, and it will go up every time you need more space. So anytime you need more space with an array list, automatically it doubles the size and then goes copies over to the new array. Okay. So what that means is that they can easily kind of grow and shrink, but it also means that you will have maybe less allocations than using just a basic array. Okay. This is what you want to use most of the time. 99% of the time, almost, or 90% of the time, the fastest thing to use is an array list. Okay. There are some cases where a linked list on the other side can be a little bit faster. Okay. So where this is really good, array lists are really, really good if you want to iterate through them. If I want to do a for loop through them, they're really fast. Or if I want to go and say, give me the 5th element, that's really easy to do. It's really easy to get the 5th element or the 100th element. It's really easy to say, I want this index, and go get it. Some of those things are not as easy with a linked list. So a linked list looks like this. There's not an array there. Linked list is not backed by an array. Okay? So what we have here is a collection of what we would call nodes. Okay, that's the formal term we use for this. So it's a series of nodes. Okay, so at the beginning here I have the head, and the end I have the tail. Okay, the head and the tail are just to keep track of where the beginning and the end is. They don't actually contain any data. Okay. In the middle is where all my data is. So in the middle you can see I've got 4 actual elements in this linked list. Okay. So I've got element 0, 1, 2, 3. Okay. Now, what are these lines here? Well, those lines here are pointers, or references. So the head points to, well, what's the next element? The next element's 0, next element's 1, next element's 2, next element's 3. So if we're iterating through a linked list, the way we do that is we follow those arrows. Does that make sense? We follow those pointers, jumping through memory. This also means that these, because of how this is set up, these nodes don't have to be in the same place in memory. Okay? When creating an array, all of these elements are in the same place. They have to be a common memory block or contiguous memory block. I can't have some of the elements are here and some of the elements are here or somewhere else in memory, which is actually really good for performance because that makes it fast. Anytime I have to jump from this part of memory to another part of memory to another part of memory, that slows down my access into memory. That make sense? So that means that this is slower to iterate because I have to follow all of these pointers. I have to go jumping around in memory through this spaghetti. Okay. Now, one of the things, if you look at the definition of a linked list in Java, the linked list class, you'll see that it says that it is a doubly linked list. Okay. Doubly linked list means not only that it has pointers going this way, going forward, it also has these pointers on the top going backwards. Okay. The reasons those are there, these pointers down at the bottom lets me iterate forwards, but it gives me no way to iterate backwards. If I just had those arrows at the end, I couldn't say, well, what's the element before 3? I wouldn't know. I wouldn't be able to tell you. I have no idea. So the link, these extra links, the backlinks, give me a way to iterate backwards through the list. So I can iterate forwards or backwards with a linked list that way and do it efficiently. Relatively. Still not as fast as an array, but fast enough. Okay. Now the caveat there, both of these have a method that you can say get and say give me the index at 3 or 5 or whatever. Now if I say get 3, it's really easy over here. I just say, oh, I want 4. You want the 4th element? Here it is. It's 4. Right? If I want to get the 4th element here, I have to start at the head. Okay, go to the 1st element, go to the 2nd element, go to the 3rd element, go to the 4th element. It takes me a lot more work to get any element that's not the 1st or the last. Does that make sense? So calling the get methods and the set methods is a lot slower with the linked list versus add and remove. Adding and removing from the ends is very fast because I don't have to move much around to add, to insert here at the beginning or insert at the end. Versus adding and removing in the middle here or wherever, it takes a bit more work because I may have to shift some things around. Does that make sense?
So if I were to add like between 1 and 2 in the linked list, effectively
still
you just
have
change
to.
where the pointers are pointing to.
Right. I just put a new thing in, point these pointers at the thing in the middle, and we're done.
Huh.
The problem is you have to make sure that you have to get there.
Right.
You have to find where you're going to insert. So if you're not careful and you just say, well, insert, say, add 3, you still had to iterate. Or add 100, I still have to iterate to the 100th element. And then, so it actually is still slower. So it is faster. This works faster if I'm working with iterators. Okay, so I really have to, the big thing to know there, this works just fine whether I'm using the enhanced for or whether I'm using the regular for loop. This is really, really slow with the conventional for loop. Does that make sense? This is fast. This is reasonably performant if you're using the enhanced for, but definitely don't use a regular for loop with the linked list because it'll be really slow. Does that make sense? And that's why you need to understand that there's a difference there. Okay. And that's one of the reasons that we have the enhanced for is they work better with these kind of things. Does that make sense? That's why we have for each loops for things like that. Now, to briefly talk about, I said these are nodes. So these nodes in the middle are actually objects. And the data type for that looks a little bit like this. So if I say node E, it's got a few properties on it. So it's got first, it's got the actual element, the actual data. So this may be E data, and it's got the previous link. So this would be node E would be the link to, or sorry, let me do next, node E. Great. So if we were to actually look at the node class, those are the actual fields that exist on it. Okay. So you can think of that. What that means is because we're looking at this, how much space does a single node take up? How much memory do I need for a node? So I have E here as the first item. Remember, E has to be an object per generics in Java, right? So if I'm looking at reference takes up 32 bits, right? Reference takes up the same space as an integer. So this here, 32-bit, 32-bit, 32-bit. So every node in a linked list requires 96 bits. There's no way around that because it's a doubly linked list. That's one reason why we sometimes will use singly linked lists to save on memory usage, okay? Because there's an additional cost there. So for every linked list that you have, you need 96 bits per node. Versus if I use a array list, how many bits do I need per node, per item that I put in an array list? 32, straight up 32. So if you have an array, of 100 items, or array list of 100 items, or a linked list of 100 items, the linked list will always take up 3 times as much memory. Always. So just be forewarned on that front. So there's a lot of kind of back and forth of like which is more performant in which situation, but that's one of the many reasons why most of the time just use array list, because there's a lot of things that sound appealing about a linked list, but there's also a lot of downsides. But do be aware that's there. You want to write your code in the way that it'll work well with either one. For constructors to the ArrayList class, I won't go over the linked list because really I would strongly recommend you use ArrayList for everything. There's first the empty constructor, doesn't take any arguments. That's going to set the default capacity to 10. Going to start with space for 10 items. It'll grow as you need more. Okay. There's a second constructor where you can set the capacity, and that will tell it already to start with this much room. So when you know how much space that your array list needs to have ahead of time, you can save on allocations by telling it to be this big. Does that make sense? So that means it doesn't have to copy, it doesn't have to grow, because you can immediately tell it needs to be this big. So definitely pay attention to when you can hit that. You can also call ArrayList that takes a collection, and this will create a copy of whatever's in that collection. Now remember, collection doesn't have to be lists. So you could be copying this, use this to copy it from one kind of thing to a list.
So if you do initial capacity, can you still grow that?
Yeah, both of these grow. It will start at that. So if I'm, for instance, one of your problems was to concatenate 2 lists together, right? Well, I know that the size of that product is going to be the sum of the 2x. So we definitely want to hint it and say, okay, it's 5 plus 3. So we want to do that whenever we can. We can hint it, but if we don't for sure know what size the array is going to end up with, we can still use this and start with it. But if I have a good idea of how big the array is going to end up being, I can make things run faster by initializing the size. But either way, it will still continue to grow. It can still get bigger from there. And one thing to know there, typically it will automatically get bigger. It doesn't typically get automatically smaller in terms of capacity. Okay. So most common methods that we use with ArrayList, you can get the size using size. Note that that's different than strings. Strings, it's length. Strings and arrays, it's length, versus here it's going to be size. So any collection you work with is size, is how many things are in there. So size is how many things are in there. Capacity is how much room there is. There actually is no way to get the current capacity of a list, an array list. You can set it, you can change it, but you can't read it, which is kind of intentional. So you've got the size. You can use a get to get something in a specific index. Use set to set something in a specific index. Just a reminder, these work really well with an array list. If you're ever using a linked list, you really want to avoid those two. Okay? Because they're very natural and they work great, again, with an array list, but they don't work well with the linked list. They're not very performant. even though they do exist. Okay. There's also add and remove methods to add things in, to remove things out, because remember, I can't, if I try to set here, one thing to know, this will throw an exception if that's not all, if there's not already space for it. So if there's not already, if I have an array array list that's size 4, well, I can't say set index 4 or index 5. It won't automatically grow it if I call set. It will just throw an exception because that index is not on. So if I need to add things to the list, I need to call add. So the first version of add just takes an item. This will add in an element, add a brand new element, and it will always add it to the end. The reason it adds it to the end is because that's faster than adding it to the end. Because you just add it to the end, increase the size, we're done. As long as there's enough capacity. Okay. There's also a version that takes an index and an element. This version does what we call an insert. So if I need to put it in the middle, I don't want to put it at the end, then that's the version I use. Again, there is a cost to that because if I do an insert, well then I have to move everything after it. I have to shift it back a space. So that means that the bigger my list is and the closer to the beginning it is, that gets more costly. Versus there's also removes. So we got two different removes. One that says remove it at this specific index. So if I know I want to remove the third item, I would say remove 2. That would remove the third item. Or if I want to remove a specific object, like let's say I have employee John, and I want to remove employee John from the list. So I'm going to call this version. And that's going to remove that item in the list. And the way it finds it is using the equals method. So if you're using this version of remove, you have to remember that your equals has to work. Okay. By default, if you don't implement equals in Java, it just compares the memory references. So you want to make sure that if you're using this version of remove, make sure that you've implemented equals on the object where you're using in that list.
Why does it take an object and not be?
Very good question. The answer is I don't completely know, except that I think they were trying to be more general. Yes, I would argue that shrug probably needed.
Okay.
But that's the way it's written.
Okay.
It can technically take something that's not the same type as the list. Which kind of works, when you add it, it does have to be that type, but when you remove it, it doesn't have to be. It just has to be something that's equivalent, where the equals returns true.
Right. Okay.
So I could say this is a list of, technically it would be valid to say, hey, I've got a list of employees, and I could try to remove a customer from the list of employees. And if the equals method comes out true between those two things, we'll remove that employee where equals is true. Okay.
I mean, it won't, basically nothing will happen, but it's syntactically correct.
No, it could potentially, something could happen. Depends on how you write equals. Okay. So one of the things you want to do when you're overriding equals method, the first thing you should do in the equals method, you should always compare object A and object B and make sure they're the same class.
So
And then just stop if they're not the same class.
So equals say is set to compare the name property.
Yeah.
It can still remove them if they have the same name.
Yeah, it could still.
Even if they're different objects.
Yeah, it could. It depends on how you've written it, right? So let's say you have the person interface up at the top, and your person has a name. Well, employees and customers are both people.
Yeah.
So if you're saying, if you've written your equals based on that get name across there, well then you could potentially have a cross. So you have to be very careful about when you're writing that equals method, when you're overriding equals, because it affects a lot more than just, the effects are pretty broad with equals because it's used in a lot of places. including like here where it's kind of used behind the scenes. I can also, similar to how I have with strings, I can say index of and last index of. These work basically the same way. There's an index of and a last index of on string, which looks for where does a substring occur. There's also an index of and a last index of on a list. And this says, well, where's the first occurrence of this, or where's the last occurrence of this object? And again, similar to like where remove uses equals, these also use equals. And similar to how remove decided to have objects, these also use objects. See that? So weird. Yeah. So it's usually the case, yes, this will be, you want it to be the same type as the array, but there are maybe some weird cases where you might say remove or index of with a different type than what's in the list. There are times that you want to do that maybe, if you're trying to have equals behave in a special way. Okay. If you want to read more about the list, there's a tutorial here. They've got quite a bit more about talking about lists, but that should give you an overview of what are the methods that you need to know about. Okay. There are a lot of methods on the list class. There are a lot of methods on the string class. The hope is I'm just pointing you towards these are the most commonly used ones, and these are what they do, because it can be very easy to get lost in the documentation. We'll get to maps as suspected tomorrow, because we're right at time, so we'll do that tomorrow. I hope that's given you some background to lists and arrays, maybe a little bit more than what you got from the quick reference guide, but that will be helpful as we'll move more into using them. Yes.